Hello everyone. So today we are here with the Good City paper of 2019. Let's begin with the questions which are included in the syllabus of this year. So this is the first question which is based on vectors. Okay. So the adjacent sides of the parallelogram are given. The angle between the sides is given. And we are supposed to find area of the parallelogram. So we know the formula for area of parallelogram is magnitude of A cross B. Now, because cross product is given, we can look for the formula magnitude A into magnitude B into sine theta. Also, magnitude B is 2 times magnitude A and theta is angle between the sides pi by 6. So this becomes 2 magnitude A square, sine pi by 6 is half. Now what is the magnitude of the vector? It is 2 minus 2, 1. So magnitude of vector A is square root of, that makes it 3. So we will write 3 square, that is 9. So the area of the parallelogram is 9. It's such it is a simple question. The only thing is they have not given us vector A and B directly, but then we have to use the magnitude of A cross B formula. The question is distance of point of intersection of line and plane from z-axis. So first we have to find the point of intersection. This is again a question of three-dimensional geometry. So to find the point of intersection, let us use the line and find the general point of the line. So this is z upon minus 1, which is equal to say lambda. So x is minus 1 plus 2 lambda, y is minus 2 plus 3 lambda, and z is minus lambda. Let's put this in the equation of the plane. Because that's a common point to the plane and the line. So we can simplify and get the value of lambda. So find lambda from here and we can put that value in this point, I mean x, y, z, so that we can find the distance from the z-axis. Yeah, it turns out that the question is wrong because we are having 4 lambda, minus 3 lambda and minus lambda. Lambda is getting vanished from the equation. So in order to simplify, let us change the equation only to see how it is solved. Otherwise this question was wrong in the paper. So it becomes, let's see, we'll put this as plus 1. So I think we can get the value of lambda now. So it is 6 lambda minus 5 lambda minus 3 lambda. 2 lambda equal to 0. So lambda is equal to 0. And if we put lambda 0, we'll get the point as minus 1, minus 2 and 0. Its distance from the z-axis would be that is root of 5. Option B. The question is angle between line and plane. So we know the formula for this is sine theta is equal to b dot n upon magnitude b into magnitude n. Modulus, of course. So what is b dot n? First of all, over here, this is the value of b and n will be 2 minus 2, 1. So let's find b dot n. Write b here. 2, 2, 1. So b dot n is 4 minus 4 plus 1. And the magnitude of b and n is going to be same because we're going to square and add them. So that makes it like 9 and 1. So do we have sine inverse 1 by 9? No. That means we will have to take a triangle and convert this to one of the form here. So opposite and hypo. That means the third side will be 81 minus 1, root 80. Root 80 can be written as 4 root 5. So that is tan inverse 1 by 4 root 5. So if straight away the angle is given, well and good. Otherwise you find from the triangle, then you can get any one of the options here. So this again is a question on three-dimensional geometry. We are looking for image of a point in the plane. So if you will notice, like the earlier video which I had taken up, also we did only 2 papers and that made up to 10 questions. So in Good CT, a lot of weightage is given to the 3D topic and vectors. Okay, so the image of the point in the plane pi is, so we have taken the image, we know that M will be the midpoint, so let's find the midpoint. 1 plus 3 by 2, 2 plus 6 by 2, and 3 minus 1 by 2. This will give us the point on the plane. So this is 2, 4, and 1. Now, for the normal, we can take vector VA, we can take vector MA, any vector. So I'm taking vector MA, that is 2, 4, 1, or I'll say AM, not MA, AM. Okay, AM. So 2, 4, 1. For the normal, we'll take vector AM, so that will be M minus A, that is 2, 4, 1 minus 1, 2, 3. So 2 minus 1 is 1, 4 minus 2 and minus 2. So the equation of the plane will be r dot n is equal to a dot n, and if we want to write the Cartesian form, it is ax plus by plus cz is equal to, anyways here we will take the dot product. So what is the normal? That will become the coefficient here, and a dot n actually here means the point on the plane and the dot product of the normal here. So 2, 4, 1 dot 1, 2 minus 2. That is 2 plus 8 minus 2, 8. Let's see which option do we have now. X plus 2y minus 2z minus 8. Oh, not this one, sorry. It is the option. This has plus 2z. So this is a question based on relation and function. Now in here, we have fx is equal to x square plus 3x plus 4, which is a quadratic equation. When it comes to questions and functions, where we are asked whether it is 1, 1 and onto, and it's a function from r to r, then for linear function, it is always going to be 1, 1 and onto, and for quadratic, it is always going to be not 1, 1 and not onto. That is many 1 and not onto is the answer. So here we have a question on binary operation, and to find the inverse, first thing we have to do is find the identity element, which is A star E is equal to A. E is the identity element. Going according to the operation given here, we have the value of E as 10. So this gives us the identity element. It's commutative, so we are not looking for E star A again. And for the inverse, we should have A star B is equal to E and also equal to this. But since AB upon 10 is same as BA upon 10, we'll not consider this one. We'll just take one of the side. E is 10. So B, which is the inverse, that is 100 upon A. So let's find, first we will have to find 5 asterisk 8. That is 5 into 8 by 10. 40 by 10 or 4. So the inverse of this element means inverse of 4 in this operation, and inverse is 100 upon the element. That's 25. It is not inverse like in real numbers. Over there, inverse of a number or a reciprocal is simply 1 upon, but here it is defined as 100 upon a because the operation is defined as ab by 10. So here we have to find a inverse x, and for a inverse x the function should be 1, 1 non 2. And over here if we notice, the function will be 1, 1 because there is not going to be any value which will be repeated, or if it is natural number we can just look for the numbers, like put in different values and check. So when you put 1, then 2, so none of the values are repeated. Of course there are more values to it, but the problem is that the range of f is not natural number. It begins from 4, which is not equal to the codomain, and hence f inverse x will not exist. So the question here is sine square sine inverse half, tan square sec inverse 2, and cot square cosec inverse 4. So if we were to have, this is good, sine and sine inverse, but here we need sec and sec inverse, same way cosec and cosec inverse. So right, this is actually sine square of sine inverse half, which means sine of sine inverse half the whole square. So then sine inverse will be nullified and the value will be half square. So we'll be applying the same everywhere. Sine square sine inverse half, but for that we need sine and sine inverse. We need sec and sec inverse. So converting tan square to sec square theta plus 1 and cot square to cosec square theta plus 1. So this becomes half square, 2 square, 4 square, okay, because cosec and cosec inverse will get nullified, and simplify this, you will get 89 by 4. Again, a question on inverse trigo. The easiest way to do this is convert cos inverse to tan inverse, and this is adjacent and hypo, so the opposite side will be 3 by 4 it is, and we will apply tan inverse plus tan inverse. So tan inverse x plus tan inverse y formula is tan inverse x plus y upon 1 minus xy. That gives it as 10 of tan inverse 12 minus 6. And if you must have noticed, the product is 6 by 12, which is less than 1. So we have applied this formula. So this is 17 by 6. So 10 and 10 inverse nullified, value is 17 by 6. So this is cos of cot inverse, again a inverse trigonometric question. And now because it is cosec here, we need to convert this to cosec inverse. Cos is adjacent upon hypo. So the opposite side will become 1 minus a square. Okay, this is a by 1. Nothing is written here, means it is a by 1. That is adjacent upon hypotenuse. So cosec inverse will be hypo upon the opposite, 1 upon root of, sorry, we have to write cosec inverse first. Yeah, cosec inverse of 1 upon root of 1 minus a square. So now cosec and cosec inverse will be nullified, and we have cot inverse of 1 upon root 1 minus x square. So we'll make another triangle now, in which now this is the adjacent and this is the opposite side. So adjacent 1, opposite So the third side will be 1 minus a square plus 1. So let's convert cot inverse to cos inverse now, which will become adjacent upon the hypotenuse, and cos inverse being nullified, we have 1 upon root of 2 minus a square. This is a determinant. Let's expand it. Sine square into sine square. Sine theta raised to 4. Minus of minus will become plus, and cos theta raised to 4. So going with the identity a square plus b square, which is a plus b the whole square minus 2ab, we have sine square theta plus cos square theta, because that will be our a and b, the whole square minus 2 sine square theta cos square theta. This is 1, and if we need to apply the formula, we need to multiply divide by 2. So that makes it 1 minus half sine square 2 theta. Now we don't have any option like that, but we have one more. It is not cos 2 theta, not this. So let's convert this to cos square theta. That's 1 minus cos square theta. 1 minus half plus half cos square 2 theta. So 1 minus half is half, and later on taking half common, we have 1 plus cos square 2 theta. That's option B for us. So in this determinant equation, we have 1 factorial, 2 factorial, which are small values to be obtained. So we'll find the values. This is 24, 3 factorial is 6, 24, and 5 factorial is 120. Now you may look for direct expansion, or we'll be doing this. C3 changes to C3 minus 3C2. So after applying these two operations, the determinant reduces like this, and we have 2, 6, 12, 48 as a value. But I would like to reduce it more, so we'll be multiplying the first column with minus 3 and subtracting here. So this becomes 0, and this will become 48 minus 36, 12. So on expansion we have 24, but in the question it says it is 2016K. So the value of K will be 24 upon 2016. So calculate and see what the option is. You can write the option in the comment box. Once again, for a question on determinant, and we want 1 upon x, 1 upon y, 1 upon z. So let's divide, or take x common, divide by x in the first row. You can see there is x here, y and z. So we'll go row wise, or we can say taking x, y, z common from the first row, then from the second y, and z from the third. So 1 upon y plus 1, 1 upon y plus 2, 1 upon y. And keeping an eye on the right hand side, we want 1 upon x plus 1 upon y plus 1 upon z. So we will add R1 changes to R1 plus R2 plus R3 we will do. So After that, we will get 1 upon x plus 1 upon y plus 1 upon z plus 3. So I'm going to write it common directly. And the first row will become 1. Over here also you'll get the same. So before expanding, let us try to get as many zeros as possible. And that will be possible by taking C2 changes to C2 minus C1 and C3 changes to C3 minus C2. So of course we'll apply this operation first and later on this one, but we'll do both of them in the same step. Or we could take C3 minus C1 also. So first we are taking C3 minus C2, 0, minus 2 and minus 2. Plus 2, plus 2. And C2 minus C1 now, 0, 1 and 0. So now let's expand it. It is 2. 2xyz. So I have written that 2 ahead. And over here if we compare this, we see it is 10k. So 10k is equal to 2. That means k is 1 by 5. So in this question we are given matrix A as well as its inverse matrix. Both the matrices are given. So let's first find determinant of A to check whether it is 1 by 5 or something else so that we know what is adjoint A. So we are finding determinant A, expand it and get the value. So you find the value of the determinant and it turns out to be 5. And so this value is our adjoint A because the formula is determinant 1 upon determinant A into adjoint A. So our determinant A is 5, so that is good, and this is determinant adjoint A. Now in adjoint A, this value is the second row, third column entry. But actually this is obtained after taking transpose and hence we are looking for P2 entry. So that is third row, second column to be removed and it is 1, 2, 2, 2. And of course minus 1 raised to 3 plus 2. That's how we find the cofactor. So minus of 2 minus 4, the value is 2. So our alpha value is 2. The only confusing thing here is some students look for alpha as 2, 3 and that turns out to be wrong. You should remember that adjoint A is actually obtained as transpose of the cofactor. So first interchange this and then look for the cofactor. Matrix AR is given over here and R is 1, 2, 3 and so on. We have to look for determinant value of AR. So let's find determinant of AR is R minus 1. Let's find it out. What is it? R square minus R minus 1 whole square, which is R square minus, okay. So finally it is 2R minus 1. So we are looking for summation R is 1 to 100 of 2R minus 1. So that is 2 summation R minus summation 1. Obviously summation is from 1 to 100. So the formula for summation R is, if it was n up till n terms, it would be n into n plus 1 by 2 and summation 1 is n. So instead of n we have 100. So this is 100 into 101 by 2 minus 100. So this is 100 into 101. Then take 100 common. So this is 1, 0, 0, 0, 0. And it is written root of this. That means we have to write this is already 10 raised to 4 and square. So that root and square will be cancelled out, which can be written as root 10 raised to 8. So value of k is 8. So these were 15 questions of the paper. Now the next 15 questions I'll be taking up in the next video. So do like, share and comment. Also subscribe to the channel. Thank you.